May peace and blessings be on you. This video is brought to you by Physics Hunters. Hunt your physics-related content in Physics Hunter. I would like to initiate with a quote. The expert in anything was once a beginner. So practice yourself to become an expert in whatever you like. So today's topic is about compound microscope. What is a compound microscope? Already we could have discussed in the previous video about the other optical instrument, that is a basic instrument, simple microscope. And now we are going to discuss about compound microscope. What is actually, to magnify the things better, to zoom out better, we can use compound microscope. What does it actually contain? It consists of two converging lens. It consists of two converging lens. So that is one lens, we call it as objective lens, right? And the other one we call it as eye lens or eyepiece. So these two converging lens, one we call it as objective lens and the other one we call it as eye lens. So these are the two lenses that we have used. What are the things that we have to use for objective lens and eye lens? So objective lens, we use very small focal length, is of very small focal length and short aperture, and it is short aperture. And if you will see about eye lens, it is of moderate focal length. The eye lens is about moderate focal length and large aperture. So this is a basic thing about the two lenses. And these two lenses should be mounted coaxially. That means the principal axis being the common one for them, right? At free ends of the tube. At free ends of the tube that can be adjusted, right? And it is of suitable fixed distance in which the image can be clearly seen. It is of suitable fixed distance from each other that can be adjusted, right? This is a basic fundamental idea. So it is of objective lens, it is of eye lens. Objective lens very small, short aperture, eye lens moderate focal length, large aperture, and these two lenses should mounted coaxially at free ends of the tube of suitable fixed distance, right? So this is a basic idea of it. And now if you see the thing, you can be able to see the diagram over here, right? So you can be able to see the object AB. The AB is the object which is placed close to the object, that is objective lens, right? That is called as objective lens of optic center O1. And if you see that the U is the distance of the object, so from O1. So from AB, the object, if you analyze if you take any two rays to be passing through the lens, so one is parallel to principal axis or another one is passing through the optic center, obeying the rules, it will be converge and form at A dash B dash. Suppose if you have, this is your object and after passing through it, here the image will be formed. This is your B dash A dash where the image will be formed according to the objective lens. So AB held perpendicular to the principal axis in front of objective lens beyond its focal length F0. So you can be able to see where it is placed here. And it will form a real and inverted image A dash B dash. So now this A dash B dash will act like an object for the eye lens. If you see this one, this A dash B dash will act like an object for the eye lens. So whose position is adjusted such that this A dash B dash lies between the optic center and the focal length of eye lens. So because of that, what happens here, you will be getting here the virtual and erect. Suppose this is your FE and this is your A dash B dash. It lies in such a way that it lies between the focal length and the objective optic center. So you will be getting a virtual and erect image or magnified image which is formed at B double dash A double dash by the eye lens. So if you analyze B double dash A double dash, it will be a virtual and erect with respect to B dash A dash, but it will be real and inverted with respect to AB. And this final image A double dash B double dash is at least distance of distinct vision, capital D. So this is the detail about it. So let me recap it. AB held perpendicular to it, obeying the rule of ray optics. It forms an image, real and inverted image, closer to the eye lens, right? So real and inverted images. A dash B dash will act like an object for eye lens, and it can be adjusted between the focal length of eye lens and optic center to form a virtual and magnified image B double dash A double dash by the eye lens. So this is a formation of the eye lens. So you have AB, A dash B dash, and final image B double dash A double dash. So what are all the things that we have here? You have AB, that is your AB held perpendicular to the principal axis, right? And in front of the, it is this is nothing but this is placed in front of the S0, and it forms a real and inverted image. It forms a real and inverted image A dash B dash. This A dash B dash will be acting like a object for the eye lens. For the eye lens. As you know, this AB is placed closer to the objective lens, and you know that this A dash B dash is formed near the eye lens will act like a object for the eye lens, whose position is adjusted between the optic center 2 and focal length of eye lens, so that it will be resulted to form a virtual and magnified image. Virtual and magnified final image A double dash B double dash. So according to this ray diagram, if you see, A double dash B double dash will be a virtual as well as erect with respect to A dash B dash. But the same A double dash B double dash will be real and inverted with respect to AB. And this A double dash B double dash is at least distance of distinct vision. Least distance of distinct vision. Right? So that means I can say that O2 B double dash will be taken as capital D. Right? And to find out the magnifying power for this microscope, compound microscope, can be obtained by, as usual, that angle subtended at eye by final image. I can say that always you keep this in your mind. Angle subtended at eye by final image, that is A double dash B double dash according to this, divided by the angle subtended at eye by the object. Right? So if you keep this in the mind, you will be getting easily. So M is equal to tan beta divided by tan alpha. So we have to find out what is tan beta and what is tan alpha from the diagram. And we have to refer two triangles for tan beta and tan alpha. What is beta? Angle subtended at eye by final image. You can be able to see now the angle subtended by the final image. You can be able to get this one. A double dash B double dash O2. This triangle you have to consider for the beta. So tan beta will be A double dash B double dash divided by O2B double dash. This triangle. And for considering tan alpha, consider a same line with respect to B double dash A double dash imaginarily and mark that point as A1 with the same height of that of AB. So that you will get a triangle, angle subtended by the object. This is your considered triangle. I have to do it. So according to that, tan alpha I have to substitute. That is A1B double dash divided by O2B double dash. This A1B double dash is similar to that of AB only, right? Same height. So I can write whatever I got it here. So that what is tan beta I obtain now? It is from the triangle. What is the triangle I have referred here? Triangle A double dash B double dash O2. Here the triangle is A dash O2 B double dash, right? So this is, that is not A dash. Instead of telling A dash, right, I can say that it is A1. It is A1 because I have considered a parallel line over here, right? So it is A1O2 B double dash. So in tan beta you will be getting A double dash B double dash divided by O2 B double dash, and tan alpha will be A1 B double dash divided by O2 B double dash, which can also be written as the same height AB by O2 B double dash. So your M can be tan beta by tan alpha. So I can write A double dash B double dash by O2B double dash divided by AB by O2B double dash. Is O2B double dash, O2B double dash is same. So that you will be getting the final answer A double dash B double dash divided by AB. Am I right? A double dash B double dash, which is nothing but it is obtained as by AB. For my convenience here, this is the one I have got it. And what I am going to do here, I am multiplying A dash B dash by in the numerator and the denominator to this magnifying power, what I get to get the desired result. So when I multiply and rearrange it, I can also write this as A double dash B double dash by A dash B dash into A dash B dash by AB. So this A double dash B double dash is final image by first image. So this will talk about the magnification of islands. And the second one is A dash B dash by AB. That is first image by the object. This will talk about the magnification of the objective. So your total magnification is the product of ME into M0, right? So this is the first information. What is ME here? It is A double dash B double dash by A dash B dash. What is M0 here? A dash B dash by AB, right? And from the basic principle of simple microscope, we obtain that let the magnification of the islands which is forming a virtual image, your formula is 1 plus D by FE. Consider this as 1, where capital D is the least distance of distinct vision and FE is the focal length of islands. And if you consider M0, it is A dash B dash by AB. That is, you can be able to see that this can also be, as you know, that V by U is equal to H dash by H. In the same sense, A dash B dash by AB can be written as O1B dash by O1B. According to this, O1B dash is V0, which is towards left, minus V0, and this is minus U0, right, with respect to this. So consider this as 2. And from the main magnification, which is a product of M0 into ME, you can substitute it that M0 is V0 by U0 and ME is 1 plus D by FE. So you can be able to get the formula 1 plus D by FE into V0 by U0 is your magnifying power formula. And of course, the length of the microscope tube. Length of the microscope tube is L is equal to V0 plus UE. This is the condition you will be getting it for your, this formula will be suitable for when the image is formed at the least distance of distinct vision. When the image is formed at least distance of distinct, that means I can say when the final image is at near point. This condition is suitable for, right, when the final image is at near point. This is the first condition. the same thing that you can repeat it. So that, say for example, you have this formula, m is equal to this, you will be getting 1 plus d by fe into v naught by u naught. If I say that AB lies close to F naught, your U naught will be O1B, which is nothing but approximated as it is very closer. It is O1 F naught. It is the focal length of the objective. So U naught, you fix it as F naught. As A dash B dash is formed very closer to the islands, right? So if your A dash B dash is very closer to the islands, right? In that sense, you will be getting your V naught, which is nothing but your thing that is totally from the diagram O1B dash minus, that is your totally you will be getting from the whole length. So say for example, what is the total V naught distance? As A dash B dash is formed very closer to the lengths. So your resultant will be, your V naught will be approximately length of the tube. It is approximated as L. How? It is as very closer you are approximating and neglecting as feeble distances. It is O2, O1. So if you consider this L, you can also write this formula as, instead of writing V naught by U naught, V naught L you write, as we are getting it here, and then U naught F naught we have approximated, right? And then it is 1 plus D by Fe, right? As F naught is negative, you can maintain the minus sign over here, right? So this is your thing. If your magnification is negative, I can say that the image will be inverted. Image is inverted. And for large magnifying power, F naught and Fe both have to be small, right? For the that means you can be able to see out of that F naught is lesser than Fe. This is your idea. And if you see about your thing, when the object is like we are forming that, when the image, final image is at near point. Here we have one more thing, like when the final image, right? So when your final image is at infinity, the same idea you extended, it is your infinity condition, your final image. There are two possibilities to be here. The same idea, same right diagram, AB is placed, you apply the rules over here, parallel and passing through the optic center, and it forms an image B dash A dash, which acts like an object, and it forms a final image, which at F, like it is placed here, it will form an image at B double dash A double dash. So which is a final image we here at V is equal to capital D. In that condition, if you see here the magnification, M naught will be L by F naught. M naught will be L by F naught, because you can be able to see the length of the tube here, right? As already we got a magnification, and ME we have, right? ME is nothing but like final image capital D, and due to this FE, right? D by FE. So this is your idea of M naught and ME. By applying the same concepts what we have discussed, you will be getting it. And in which you will be obtaining this as ME is equal to A double dash B double dash by A dash B dash. Applying this formula, you will be getting it, in which it is nothing but B double dash O2 by B dash O2, which is nothing but D by FE, right? So ME is D by FE and M naught is L by F naught. In that, if magnifying power M is equal to M naught into ME, which is L by F naught into D by FE. This is another formula when the final image is formed at infinity, right? So when the final image is formed at infinity. So you have two cases. One is when the final image is formed at the near point, and one more is when the final image is formed at infinity. So it will be based on the problems you have, how they are asking. You have to draw that diagram, and then you can write the formulas. But remember the formulas for doing the problems. It will be useful for doing the problems, right? Thank you. Thank you.